Okay, so now we're going to talk about polynomial division and synthetic division. Now, because polynomial division is sometimes called polynomial long division, I'm going to go ahead and do a long division practice problem to kind of remind you of some stuff. So let's say we're taking 165 and dividing it by 7. And we're going to be generous. We're not going to worry about decimals or anything. So we're going to end up with a remainder. It just doesn't work, okay? So the first thing we do is we take a look. 7 goes into 1? No. 7 does go into 16, though. How many times? Twice without going over. So we'd take in, 7 times 2. Or 16 divided by 7 is 2, as we got the remainder, right? So 2 times 7 is 14. So we write that underneath there. And then we subtract, which is 2. And then, if you remember your process correctly, we have to bring this 5 down. Then we repeat the process. That is, 7 goes into 25 how many times? Well, 7 does go into 25, and as a matter of fact, it goes in 3 times without going over, so that would be 21. Now, that means then remainder 4, and because we're going to do a remainder, we're going to stop. We're not going to go with a decimal or anything like that. So it's just going to be R4. Now, this is very important. We took 165 and we divided it by 7. What did we get after we did that? We got 23 plus a remainder of 4, or 23 and 4/7, right? So this is kind of important because when we write remainders as polynomials, whatever we're dividing by is going to be that's what we're dividing by here. By the way, this does work. So I multiply both sides by 7. Watch what happens. 7 times 23 is 140 plus 21 is 140 plus 21 is 161 plus, well, the 4 and the 7 cancel out. That looks familiar, doesn't it? Hey, it's 165, right? But that's how we have to write remainders. Remember, that is the remainder, right? And this, I believe, is called the quotient, the result of the division, right? This is the divisor, and this is the dividend or something. But let's not worry too much about this, but this will be the quotient, okay? So let's do some examples. So how to divide polynomials. Let's say we have something that, like a cubic, right? X cubed plus 3x squared plus 7x minus 2. And we want to divide it by some sort of, I don't know, how about x plus 2? I just said plus, but I said minus. It really doesn't matter. We'll just stick with minus, okay? So what we've got is this. So we're dividing these two. Let me give myself some space. I'm jockeying this around. Okay, so here's how this works. We are going to focus on the lead term here, this x, and then the lead term here, which is the x cubed. And we're going to ask ourselves, x times what is x cubed? Oh, x squared, of course, right? Or what is x cubed divided by x? Why, it's x squared. Now this is where it gets really important. So I'm going to take, and the first thing I'm going to do, kind of like when I looked at how many times 7 went into 16, right? Went in twice. This means I have to multiply by an x squared to get these to match, because what I'm going to try to do is cancel this term out by multiplying by something. So x times x squared, which means I'm going to put the x squared that I'm going to be multiplying by right up top here above the other x squared. So x squared times x is x cubed, but there's other stuff here, right? So I need to take this x squared and multiply it by the -2, which is -2x squared. Now, this is very convenient because it lines up the like terms. Now note, we are going to subtract, but here's where the danger comes in. What are we going to subtract? All of this. Whereas before we were just subtracting a single number, here we're subtracting these two things. So what should happen is this cancel out, and it does. Gone, right? This, however, changes. 3 minus a -2x squared, and this is where people mess this up. This is why the parentheses can be so important, is actually 3 plus 2x squared, or 5x squared. And then you're automatically going to bring down this 7x and then repeat the process. So x times what is 5x squared? Or what is 5x squared divided by x? Why, it is a positive, right? Both positive. 5x. So 5x is what we have to multiply x by to get 5x squared. So we do 5x times x, which is 5x squared. And then we also have to do the 5x times -2. So positive 5x times -2 is -10x. If all works out, then we've got the like terms lined up, right? And then we're going to subtract the whole thing. This is gone. 7 minus a negative, why that's 17x, and then we bring down the minus 2, okay? Now, can we fit an x inside of 17x? Yes, let's change colors here. How about purple? X times what is 17x? Why, 17. Now, please note, we would expect x times a quadratic would give us an x cubed, and that's sure what we're going to get. This next piece we get, the last part we get, the remainder is going to be, well, the remainder. So 17 times x is 17x, right? And then 17 times negative 2 is what? Negative 34. Don't forget we're subtracting. This goes negative 2 minus negative or plus this is 32, okay? So this means that when I take, and by the way, that means our remainder, right, is 32 x minus 2's. That means when I take x cubed plus 3x squared plus 7x minus 2 and divide it by x minus 2, what do I get? I get x squared plus 5x plus 17 plus the remainder of 32 x minus 2's, right? So that's what these two equal, all right? Let's try another one. Now this one had a remainder, right? Let's try another polynomial long division one, okay? How's about x, how's about I move this down a little bit. How about I take x squared plus, I don't know, how about 3x minus 4, and I divide it by x, let's see, what do I want to divide this by? Minus 4 plus 3. Let's say I divide it by a x minus 1. Okay, so x goes into x squared how many times? That is, what is x squared divided by x? Why is x? So I'm going to have to multiply by x. Remember, it's important to start off by lining this up. And we would expect linear times linear to be a quadratic, right? So x times x, x squared, x times negative 1 minus x, or minus 1x. And then we're going to subtract. X squared minus x squared, gone. 3x minus a negative, or plus x is 4x. And then we bring down the minus 4. Now, some of you may be thinking, why do you pick that? I know how to do this already. I'll show you. So, x times what is 4x? Why? A positive 4. 4 times x is 4x. 4 times negative 1 is negative 4. Uh-oh. Or is it? What's the remainder? 0. What does that mean? When I take x squared plus 3x minus 4 and I divide by x minus 1, what do I get? I get x plus 4 with no remainder, right? Now if I multiply both sides by x minus 1, that's telling me that the factored form is. Now what that means is the remainder of 0 seems to imply that it goes in evenly, right? It means that that's a, well, we'll talk about that, but it is a root, isn't it, right? This also, by the way, does, I should write this down, does mean this, right? Goes in evenly, so there we are. Yay. Okay. Now, polynomial division is used sparingly. Most of the time we can do it, we'll do a synthetic division. I'll show you that in just a sec. But polynomial division must be used in certain cases. Like, oops. If I've got some sort of, let's say, I don't know, let's go a little bit simple on ourselves. Cubic. Oh, you know what? I also want to show you this. Let's say plus 7, right? Now I'm going to divide that by some quadratic. Let's call it x squared plus x minus 2, right? Now, if you're looking at this cubic, you may notice that it's in standard form, cubed, squared, but it's missing a term. This is not an error on my part, but what it means is that you need to write in the missing term if it's there. If it is indeed does have a missing term. So there is a 0x, it's just hard to see. We'll see why that has to happen here in just a sec, because now we're going to follow through with our normal process. X squared, x cubed. X squared times what is x cubed? Why x? So I'm going to put that over the x term, right? And then I'm going to distribute it. So x squared times x, x cubed. X times x is a positive x squared. X times negative 2 is a minus 2x. and I'm still going to subtract. So these two cancel. 3x squared minus x squared is 2x squared, right? And 0 minus a negative is going to be plus 2x. And then the 7 comes down, right? So then repeat, or same process. X squared times what is 2x squared? Well, positive 2. And then we distribute it. So we get a 2x squared plus 2x. Hey, those are going to cancel. And then 2 times negative 2 minus 4. So when we subtract, it turns out these two terms go away, but 7 minus a negative 4 is positive 11. So what does that mean? After we divide, our result is x plus 2. So what does this mean? It means that this cubic x cubed plus 3x squared plus 7, we don't have to write the plus 0x if we're not actually dividing it, is equal, so divided by x squared plus x minus 2 is equal to what? X plus 2 plus 11 x squared plus x minus 2, just like that, okay? All right, so now let's talk about synthetic division. Synthetic division is a way to divide by factors with a leading coefficient of 1. So in other words, I'm sorry, I should say divide by factor. Well, actually, I don't need to say that. A factor is of the form x minus a, right? For instance, x minus 1, x plus 2, right? And it means that in this case, the root, or the 0, is equal to the a, right? So let's say that I have some sort of quadratic, like x squared plus 7x plus 4, right? And I want to divide it by a factor, that is, I want to divide it by x minus 2, right? Now, first off, you need to, if we're dividing this by a factor, recognize that for synthetic division, right, we could do polynomial division, that'd be fine. Synthetic division is a little bit different. So synthetic division is set up like this. Let's kind of get that so it's actually somewhat horizontal, or try to get it that way. What we're going to do is we're going to list off the coefficients of what we're dividing. That is, that's a lead coefficient of 1, and then that's a positive 7, and that's a positive 4. And then we're going to put down here the root that is represented by the factor. We're dividing by x minus 2, so that means the 0 is, or the root, is x equal to 2. So we're going to put a 2 there. This is kind of important. I don't put a negative 2, I put a 2, which is the factor. We'll do some more examples. Then here's the first step. First step is bring down the 1. That is, bring down the lead coefficient, okay? So the first step is to bring down the 1. Then you multiply these. So 2 times 1, and you write that there, okay? There, that easy. Then you add these together. Then you multiply this, 2 times 9, which is 18. Then you add these together, 22. Okay, we're done. But now we have to interpret this, right? Let's read the tea leaves, yes? So we took this quadratic, so that's the squared, right? And we divided by a linear factor. So when we take a quadratic and divide it by linear, that means we should get a linear result. So it turns out this part right here, this 1 and this 9, is the actual linear factor. So this means, this translates to, well, this is 1x, and this is a positive 9, and this is the remainder. So this means that this down here, right, I already wrote it, so I'm just going to move this. This divided by this is equal to, well, x plus 9 plus the remainder, which is 22x minus 2's, okay? Now, if you actually distribute this, x minus 2 times x plus 9, right? So if you multiply both sides by this, you're going to get x squared minus 2x plus 9x, so x squared plus 7x. Hey, good match, right? minus 18, but then you're going to add the 22, which then works out to 4. If you don't believe me, try it. That is if I multiply this out. Okay, this is a little bit tricky at first. Once you get the hang of it, it's great. But first thing is when you're dividing by a factor, right? So if I'm dividing by a factor, then that means I'm dividing by this, and that's got to be linear. It's got to be 1x. So I couldn't divide by 2x minus 3. That doesn't work. I could divide by 1/3, but I couldn't divide by 2x minus 3. Now, let's try this one more time. So let's say I've got this. Let's go with a cubic, okay? Let's say I have x cubed plus, well, let's make this spicy. Let's say it's negative 2x cubed plus 3x squared minus 7x minus 15, right? And I want to divide it by x plus 2, right? So I'm dividing this by x plus 2. So the first step would be to take this and write out the coefficients to my cubic. Now it's the same way with with polynomial division. If I have a missing term, you know what, let's actually make a missing term out of this. That won't hurt anything, will it? What if it was just that? What would that mean? There is no 7. There's no minus 7. What is there in its place? There's really a plus 0x. So I'd have to put that 0 in there, okay? And then I'm going to be dividing by x plus 2. So what do I put here? I put a negative 2, because that means the 0 is negative 2, right? So this is a way of doing that. Now, then my first step, step 1, number 1, is to bring down the negative 2. Step 2 is to multiply. So negative 2 times negative 2 is 4. Then I add, then I multiply, then I add, then I multiply, then I add. Okay, I believe that's right. Yes, it is. Now, knowing what we know, this last term, if it's there, is the remainder, right? This is the remainder, which means that my answer, the quotient, what I get, is negative 2. Now, this is always going to drop 1 power because this is a single power. So x squared, x cubed divided by just an x, that's going to be negative 2x squared plus 7x minus 14. That's what that represents. And my remainder is 13 over x plus 2. Because remember, I'm dividing by x, right? The x plus 2, okay? So synthetic division can be very handy, especially if you have some values that are actually zeros when you're dividing. Also, synthetic division can be a lot quicker, okay? So we'll do some examples more of this later on, but that kind of concludes our intro to polynomial division and synthetic division.